We're moving on in tools of geometry with measuring angles. And let's go back and take a look at a naming convention for rays. When you have a ray, you use two capital letters representing points with a line and a single-headed arrow pointing to the right. The first letter is the starting point, and the ray runs through the second letter. And again, we are going to pronounce this as ray AB. Then we have angles. In order to name an angle, you need one of two things. You can either have three capital letters, and the vertex point is always going to be the point in the middle. The first and last letter may be transposed, but the middle letter must stay in the middle. So you could say angle ABC, or you could say angle CBA. They are the same angles. If you only have one letter, if you only have one angle at a particular vertex point, then you can just use that single letter rather than having to use all three letters. In that case, you could say something like angle B. First question, naming angles. What are two other names for angle 1? So you can see in this illustration, we have two angles that are right next to each other. One is JMK and the other is KML. And what we want to do is we want to figure out what is another way that we can say angle 1. Well, the first thing we're going to do is identify the rays and points that make up that angle. So again, angle 1 is made up of points J, M, and K. So that means that we can either call this angle JMK, or we can reverse it and say angle KMJ, as long as the M is the middle letter. We're moving on to our next postulate, which is the protractor postulate. And that states, consider ray OB and a point A on one side of ray OB. Every ray of the form ray OA can be paired to 1 with a real number from 0 to 180. So as you can see, we have this protractor. We have ray OB going through whether you want to say 50 or 130, depending on which starting point you have. And then we have ray OA running through either 40 or 140. Now the way that we can measure the angle is the measure of the angle is equal to the absolute value of A minus B. So in this case, we could do the absolute value of 40 minus 130, or we could do the absolute value of 140 minus 50. Both are going to give us 90 degrees. In identifying types of angles, there are 4 types of angles that we're going to look at. The first is the acute angle. Acute angles are defined as being between 0 and 90 degrees. The next is right angles. Right angles are exactly 90 degrees. Obtuse angles are between 90 and 180 degrees, and straight angles are exactly 180 degrees. In problem 2, measuring and classifying angles. What are the measures of angle LKN, angle JKL, and angle JKN? Classify each angle as acute, right, obtuse, or straight. So what you want to do first is to identify where exactly is angle LKN. So you can either use your finger or you can draw this on paper, and you can see that L starts at 35 degrees or 145 degrees, runs down to K, which is the vertex point, and then runs out to N, which is either at 0 degrees or 180 degrees. So I'm going to use the inner set of angles on this. And what we see is that angle LKN is equal to the absolute value of 145 minus 0. So 145 minus 0 gives us the absolute value of 145, and the absolute value of 145 is 145. That means that angle LKN is an obtuse angle. Next, we look at angle JKL. Now, angle J, or point J, is at 90. Then it moves down to K and moves out to L. And L is again at 145. So angle JKL is equal to the absolute value of 90 minus 145. And that gives us the absolute value of negative 55. And the absolute value of negative 55 is 55. 55 being greater than 0 but less than 90 means that our angle is acute. Finally, we're looking at angle JKN. Again, point J is at 90. It runs down to K and then out to N, which is at 180 or 0. So angle JKN is equal to the absolute value of 90 minus 0. 90 minus 0, of course, is 90, and then the absolute value of 90 is 90. And since this is right at 90 degrees, that means that angle JKN is a right angle. In our next problem, using congruent angles, we're going to use congruent angles. So what are they? Angles with the same measure are congruent angles. So if one angle is 50 degrees and another angle is 50 degrees, then they're congruent. So the question states, synchronized swimmers form angles with their bodies, as shown in the photo. If the measure of angle GHJ is equal to 90, what is the measure of angle KLM? So the first thing that we know is that the measure of angle GHJ is equal to 90. And if you find that, it is from the elbow to the armpit to the hip of one of the swimmers. Then if we look at KLM, it runs from the hip to the armpit to the elbow of the swimmer. So that means that we're looking at congruent angles. So angle GHJ is congruent to angle KLM, which then means that the measure of angle GHJ is equal to the measure of angle KLM. And that then means, since GHJ is equal to 90 degrees, that KLM is also equal to 90 degrees. Our next postulate is the angle addition postulate, and it's very similar to the segment addition postulate. Basically what we're doing is we're taking two angles and we're combining their values to get a larger angle. So if point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. In problem number 4, we're going to use the angle addition postulate. If the measure of angle RQT is equal to 155, what are the measures of angle RQS and the measure of angle TQS? And as you can see from the illustration, angle RQS is given a quantity of 4x minus 20, and angle SQT is given a measure of quantity 3x plus 14. The first thing we know is the measure of angle RQT is equal to 155. If we add angle RQS and angle TQS, we're going to get angle RQT. Substitute the quantities in, you get 4x minus 20 plus 3x plus 14 equals 155. Combine like values, combine like terms, you end up with 7x minus 6 equals 155. Add 6 to both sides, 7x equals 161, divide out the 7, and you end up with x equals 23. So now we're going to substitute 23 in for each of the x's. Start with RQS. We get 4 times 23 equals 20. That gives us 92 minus 20 and an eventual answer of 72. For SQT, 3 times 23 plus 14, that gives us 69 plus 14 for a measure of 83 degrees.